This is Miss Hanson from Math 152, and in this video we will be talking about levels of measurement. There are 4 levels of measurement. The lowest level of measurement is the nominal level. The second level of measurement is the ordinal level. The third is the interval, and the fourth and highest level of measurement is the ratio level. We will be starting with the lowest one and working our way up. So starting at nominal data is name data, data that is used as labels or characteristics. No math can be done at this level of data, and all of this data would have to be qualitative only. There is no quantitative data in the nominal level of data. Some examples of nominal data include jersey numbers, names, student ID numbers, and flight numbers. Notice that even though there are some number data in these examples, these numbers do not act as true numbers. These numbers here are acting as labels. For instance, if your flight number is flight number 5617, that 5617 is not acting as a true 5617. It is acting as the name of your flight. No math can be done at this level. It doesn't make sense to add the 2 jersey numbers of your 2 favorite players. No math can be done here. That is the nominal level of data. The second level of data is the ordinal level of data. Ordinal data is data that can be arranged in an order or ranked. Subtracting is not meaningful, and this data can be qualitative or quantitative. Let's look at some examples here. For example, size of fries, like small, medium, large, that has an order to it, but it doesn't make sense to subtract. What is the difference between small minus medium? That doesn't make any sense. Shoe sizes is also ordinal data. If I wear a size 9 and you tell me that you wear a size 7, we can rank that. We can determine whose foot is bigger, but it doesn't really have any meaning for us to subtract our shoe sizes. That is the second level of data, ordinal. The third level of measurement is the interval level of measurement. Data at the interval level can be ordered, and here differences are meaningful. However, 0 does not represent an inherent 0. It simply represents a position on a scale. So if 0 does not represent an inherent 0, let's see what that means. An inherent 0 is a 0 that means none. For example, if I tell you that I have $0 in my bank account, that truly does mean that I have no money. None. An example of something that is not an inherent 0 is, say, I tell you it is 0 degrees Fahrenheit outside. That 0 degrees Fahrenheit does not mean there is no heat outside. Of course, it is very cold, but it doesn't mean there is absolutely no heat. So that is not an inherent 0. That 0 degrees represents a position on the temperature scale. It does not represent none. So that is what an inherent 0 is. An inherent 0 is a 0 that represents none. So some examples of interval data. We've seen that temperature can be an example of interval data. Year data, a list of years, that's an example of interval data. If we're talking about year 0, that does not mean none. Year 0 does not mean that no time has passed before that, so that would not be an inherent 0. And that is interval data. The fourth and highest level of measurement is ratio. Ratio data has all of the qualities of interval data except the added part that 0 does mean an inherent 0. So in ratio data, 0 truly does mean 0. Some examples of ratio data are weight. Another example is the number of years you worked at your last job. Notice the difference between this example and the example we had in interval data. If I worked 0 years at my last job, then I didn't work at my last job. 0 years truly does mean none. different from the example we talked about under interval data. So these are the 4 levels of measurement, and knowing which data falls into which level of measurement will help us as we get further in the course to make sure that we are using the correct formulas and the correct procedures with our data.